Bonsuelo, mathletes. Oh, this is a great day. It is a great day to be a monarch. We're going to talk about something called logarithms. Now, I'm going to talk a lot before we ever get to what a logarithm is, because you've never seen these before. And if you ignore this, you're going to, this little introduction, it's not even that little, you're going to regret it, because you have to get into your head what a logarithm is. Okay, first of all, technically, this statement is not true, but I'm going to say it anyway. A logarithm is an exponent. So if I'm asking you to find a logarithm, what am I asking you to do? I'm asking you to find an exponent. Okay? Make sure you understand that. Okay? So what you're doing is finding an exponent. Also, I want you to understand a logarithm is a mathematical operation. It's telling you to do something. What's it telling you to do? Find an exponent. Okay. Now, to understand logarithms, you first have to understand exponents. And I told you this a couple of videos ago. You have to understand exponents, particularly negative exponents and fractional exponents, but you also have to understand exponential equations. You must understand those three things. If you have any questions on them, get them resolved now. Okay, what do I mean by a math operation? Like addition, division, square root, log. They're all telling you to do something. Okay? So make sure you understand that. So for instance, here, when I ask you to take the square root of something, I'm saying what times itself 5 times gives you x squared, whatever, okay? That's what a radical is. It's asking you to do something. Now, just like I've said with radicals, you should read them properly. You should read and write logs properly. So first, how you read the fifth root, how you read this first radical here is the fifth root of x squared. That's the way it should be read. And it can be in radical form, as I've written here. And I can change that to exponential form. And you should know that. Now, how do you read this logarithm? It's read log base 7 of 9. That's the way you should read it. Okay? So, how can I change that to exponential form? This is the base, so it becomes the base. This is the exponent, so it becomes the exponent. And this number here is on the other side of the equation. Okay? Now, just like with a radical, you don't want to change the form unless you need to. You don't want to change the form with a log unless you need to. Okay? So we'll try and do these all in log form and only change the form if we need to. So again, just like you can change radical form to exponential form, this one would be, number one here would be the cube root of x is x to the 1/3 power. We can take log form and change it into exponential form. So it's log base 4 of 32 equals x would be 4 to the x equals 32. Log base x of 7 equals 5 is x to the 5th equals 7. And so on and so forth. Read through the examples. Understand you're taking the base and you're raising it to the exponent and then setting it equal to the thing that's basically left over. Okay. How to calculate logarithm. I'm going to show you the long way and then I'm going to show you the short way. I'm going to show you the long way first because sometimes you have to do this, but you don't want to if you can avoid it. Okay. What you're going to do is change to exponential form. So let's take this problem. Log base 2 of 8. First of all, notice it's not an equation. So I'm just going to set it equal to x. Then I'm going to change the form, and it's 2 to the x power equals 8. And now you've seen this before. It's an exponential equation. You get the bases the same, and that's your answer. Okay? So now here's the short way, and this is the way you should really be doing it. A lot of people do it the long way, and they keep doing it the long way, and they'll never understand logs as long as they do that. Okay? What you do is you change this number to that base. So how can I write 8 as 2 to a power? And 8 is 2 to the 3rd power. Now, remember in an exponential equation, you can change both sides. In a log, you can't. You have to keep the base to be whatever the base is. So I can rewrite 8 as 2 to the 3rd, therefore the answer is 3. I'm telling you what? the value of the exponent when the bases are the same. Okay? Now, there are two main types of logs. The first, okay, like when you have this symbol right here, okay, and you don't have any index written, it's understood to be an index of 2. Well, there are two types of logs that don't have the base written. First is just this, and that's a base 10. So log of 1,000 means log base 10 of 1,000. Okay, and you can read it either way. ln, it's not an I, by the way, it's ln, is something called a natural log. And it's got a log of the base e. Remember that number e. So natural log of 7 means log base e of 7, and you can read it either way. Okay? Now, let's just take a look at a bunch of examples. So you should stop and try these on your own. Remember, what you want to do is get this number to have that base. So how can I rewrite 125 as 5 to the power, 5 to a power, 5 to the third? So the answer is 3. I have the bases the same, you tell me the exponent. How can I write 1/49th as 7 to a power? It's 7 to the negative second. Remember, you need to understand negative exponents and fractional exponents. So the answer is negative 2. Remember, this is log base 10. How can I rewrite this as 10 to a power? That's 10 to the 4th power. So the bases are now the same. So even though I don't have it written, right, the base is understood to be 10, so the answer is 4. Okay, no base written here, but it's a natural log, so it's base e. So I rewrite this as e to the 2/3 power. Again, you need to understand the exponent rules, and so the answer is 2/3. Now here's the problem. I can't write, or the difficulty, I can't write 32 with a base of 4. Now is when you change the form. Notice in all these, I didn't need to change the form. But here, you think of it as equal to x, and you have 4 to the x equals 32. And what good does that do you? Now you can change both bases. So we have 2 to the 2x equals 2 to the 5th. And you can kind of just look at this and go, okay, so x is 5/2. But if you want to write 2x equals 5, that's fine. And then the answer is 5/2. Okay? We want to write 1 with a base of 13. And that'd be 13 to the 0 power, so the answer is 0. Okay, we want to write this as a base 10 because it's a log. All right, well, 100 is 10 squared. So this would be 10 to the negative 2/5 power. Now, how did that happen? The negative is because it's in the denominator and we want to put it in the numerator. The 2/5 comes from changing it from the 5th root of 10 squared to the 10 to the 10 to the 2/5 power. Let me take that a little slower. Just the 5th root of 10 squared is 10 to the 2/5 power, okay? But since it's in the denominator, we can put it in the numerator by changing the sign and making it negative. And so the answer is negative 2/5. Okay, how can I rewrite 1 over 81 as 3 to a power? It'd be 3 to the negative 4th power. So the answer is negative 4. There's nothing to do here. The bases are the same. The answer is just 5. Okay? What do you do if you can't get the bases the same and changing to exponential form doesn't help you? We'll discuss that another day. But that'll be good enough for these problems. Okay, that's it. Very important. Okay? The next file will be a bunch more examples. And again, even these, you should have done these on, tried these on your own. But if you didn't try these on your own because you weren't sure what to do, that's fine. I understand. Make sure you do the next file on your own first, and then look at the video. Have a good day, everybody. Bye-bye.